All right, so this one, whoa. This guy here? Which of the following pairs of sets? Oh, okay. So somebody remind me, what the hell does that mean?
Numbers that are in D.
The number of things that are in D. I like it. So what's that? For which part?
It kind of like the whole general.
Whole thing, okay.
Yeah.
How many things, let's look at this first guy. How many elements are in D?
4.
That's crazy. So ND is 4. How many elements are in E? 4. Now, if you do the union of them, do you end up with 8 things? No. So is this true then? Is this statement true? It would have to be 8 here, of course, right? So some of you guys, I was reading some of the stuff, and some of you guys wrote down the correct union, but then he said it was good, and I don't know if you thought, you might have mistaken what the problem was trying to say. Like, can you put these together or something? I don't know if you realized the question was asking, if you add the number of elements in each, is it the same as when you union them? Well, no, because you're not going to write the, what is it, G. You're not going to write the G twice, right? Does that make sense? So it doesn't hold for that. Another one that confused people was this guy. Right? How many elements are in here? None. How many elements are in there? None. What set do you get when you union those together? Empty set, right? So if you had an empty sack and somebody else had an empty sack and you're like, let's put all our stuff together. You still got nothing. It's sort of like when I was younger. We're like, how much money you got? None. How about you? None. Let's pool it. That's not smart. We still have no money, right? So that's an example of 0 plus 0 in set speak, right? I like it. And then, by the way, I need you to understand this. There are several homework problems that are definitely tricky. Would anybody agree with me? So it's fine. Don't feel like you're supposed to understand all of it the minute you see it. Don't feel like I'm not going to ask because I'm sure everybody else understood it. One thing I like to say is if you have a question, at least 8 other people have the same question. And you could be their hero, right? If just for one day, you could be their hero. If you just ask the question, right? Does that make sense? Okay. Anything else from homework stuff? No, okay. Don't forget, you can come see me. Mark Riley in the Math Study Center. He feels pretty good about tutoring 125. I think a few of you guys said you'd seen Mark. Yeah, okay. And also in general, just don't hesitate to ask a question if, for example, just for an example, when we get to fractions, I am going to devote some time to just going over fractions again, because I don't care what level. I've had some Calc 2 students who had trouble with fractions, right? So it afflicts everybody, right? But the thing I want to try to get you to be able to do is to get a generation of students to come in not having that issue with fractions. That would be amazing. And it kind of starts early, right? Okay. For example, so fractions are in our future, not today. So anything else with homework? Okay. I think last time we looked at this worksheet, and I don't really blame you at all. When I put you in the groups, I do like to try to push you a little bit. And it's not a freaking quiz, so you can just play with it. If you have no idea what it's supposed to mean, you just start trying something, right? So I understood a lot of you guys looked at, I love the group that told me, we looked at number 2, we said, oh God, we'll come back to that. And then we went to number 3, we're like, oh shit, let's go back to 2. And again, I understand that, but again, like homework, group work, it will occasionally push you. And sometimes it might push you further than you're currently able to go, which is fine. We'll discuss it, and then hopefully we push that a little bit better for you. So I think we finished through number 3, if I'm correct. We did number 3 last time. And let me see. I think a few of you guys weren't here, which I would highly recommend as always to watch the video from that day. But, were there any questions left over from the first 3 of those? Or were those okay now? So, looking back at this real quick, because this is a big one. This is definitely freaky. And I try to help by putting up on the board just a summation table. So, we're gonna see, you've already seen, we've done things like take our basic number system, the numeral 1, the numeral 2, and we just were like, what if it wasn't that? So we've done the pancakes and blueberries, we've done the Pac-Man, we've done the whatever, we've done all these things, the hill bones. So this is going even beyond that. Okay, what about our operations, our plus sign, and the operations? They could have been different themselves. So this is very abstract. Really obvious that this is freaking abstract as hell, right? It's not numbers, it's letters okay. But I read it the same way. So just to make sure everybody can read this correctly, can anybody tell that? Don't say anything out loud, just think about it for a minute. Don't say anything yet. What is d omega c? Don't say anything yet. And yeah, this is like a different accent. So you have, that's the symbol. This is also the same symbol. Okay. So who knows what that is? A. So D omega C is A because that's where I go. Right? Yeah, like it. Sweet. Okay. And last time we talked about why this is not commutative, so the examples were like these two. D omega B is not the same thing as where am I at? Not those two. These two. It was these two. So C omega B is not the same thing as B omega C. So it's not commutative. So again, when you first show students, when they first see an addition table or a multiplication table, it is going to be gobbledygook to them, possibly, right? Not complete gobbledygook. You guys know these symbols. This is a Greek letter, so it's new. But they're going to kind of feel the same way you felt when you first saw this. Okay, so now I want to focus number 4, because I remember, and I kind of love this. I kind of love when students are like, yeah, you can't do that. And then I say, yes, you can. And they're like, no, you're crazy. Did anybody get a chance to think about number 4 yet? Any of the groups? What did you guys come up with, anybody? Do you guys remember? Anybody come up with something for number 4? I will tell you this, they're wrong. But you can't blame them for being wrong, especially because a lot of you guys thought it was true. So you really can't blame them for being wrong. So let me give you an example. And this kind of points to a few issues I saw in the homework. I could say, is addition closed over the whole numbers? So remind me, is that true? Is addition closed over the whole numbers? Yes. I could say multiplication is closed over the whole numbers. But the set that I'm looking at doesn't have to be every freaking number possible. So I could think about, what about this set? What about the set 0, 1? Now think about it. Is that closed under addition? What does it take to be closed under addition? If you take any 2 elements, and you could take the same element, and you combine them through addition, the answer must also show up in the set you started in, correct? That's what closure means. So can somebody give me a quick counterexample as to why that's not closed?
1 plus 1 is 2.
1 plus 1 is 2, it's crazy. You gotta love a class where that's an acceptable answer. I love it. Well, because 1 plus 1 is 2, holy shit. Is it closed under multiplication? What's 0 times 0? What's 0 times 1? What's 1 times 1? That's all the combinations, correct? And every result was in this set. So is this closed under multiplication? Yes. So let me say this again so closure means to be closed under an operation. If I operate with that operation on any two elements, the result must stay in that set. That's closure, right? And we just did multiplication in every way we could with the elements in that set, and we got an answer that was in that set. Closed. Addition, 1 plus 1 is 2, that's all we need, it's not closed. It goes outside of the set to find the answer. You guys see that? There's a more complicated answer than this. This is the most immediately basic answer. Even better than that would just be 1. Is that closed under multiplication? 1 times 1 is, holy shit. Is it closed under addition? No. So that's even more basic than 0, 1. Okay, I like it. You guys doing okay so far? Okay. Think about this set for a minute. How am I creating those numbers? You can see them. Yeah. What is? Go ahead. Sorry.
Multiplying by 3 every time.
Yeah, I keep multiplying by 3. Is it closed under multiplication then? See the dot, dot, dot? Keeps going. Same way, right? 3 times 3 is in there, correct? 1 times any of them is in there, correct? 9 times 243 will eventually be in there. You guys all agree, because I'm going to get everything that is some combination of a certain number of 3's. So whenever I multiply one by another one, I'm just going to get another bigger one. What do you do? It's in there. You with me? Is it closed under addition? Immediately no, right? What's 1 plus 3? It's screwed, right? The poor little dude is screwed. If it wanted to be closed under addition, too bad. Okay, maybe. Okay. So there's a couple things that happen in the homework. A couple people were confused about odd and even. I'm not sure if that came out of a homework problem somewhere. Closure has nothing to do with odd and even unless the problem is like you have a set of even numbers. So for example, the set of all even whole numbers, is that closed under addition? Write the first few elements. Set of all even whole numbers. What would that look like? Can somebody, everybody, please write for me, not the words, but write the set of all even whole numbers. Write them all down. Every single one. But, of course, we know how to do that. I just wrote down an infinite number of numbers, correct? Okay, so even whole numbers. What would that be? 2, 4, 6, 8. Somewhere you just go dot, 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 right? Because you're like, holy shit, Jeff. I'm not going to write an infinite number of numbers, dude. Dot, dot, dot means go find the one you want. Leave me alone. Okay, you don't have to say all that. Is that closed under addition? You guys see it looks like it is. How would you kind of prove it is? What would you have to prove that's closed under addition?
Add any 2 even numbers.
Yeah.
If they're even.
The sum of 2 even numbers is still even, right? And of course, if you think about it, it makes sense. Each of them has a factor of 2, and I have 2 of them. So the result's going to definitely have a factor of 2 in it, correct? That's all it takes to be even. Now what about odd numbers? One, 3, 5, 7, blah, blah, blah. Is that closed under addition? Hell no. Immediately no, right? And of course, the reason that one is and the other one isn't is if I take any 2, that's already a factor of 2. So the odd numbers are screwed. If I had an operation that combined 3 things at once, if I defined addition to be the sum of 3 things, would this be closed under that new operation? We actually did this, I think, a while back. If I add 3 odd numbers, what's 1 plus 3?
4.
Plus 7. The result's odd, right? You guys see that? I think we actually, I don't know if you guys remember this, but I'm almost certain we proved that earlier this semester. The sum of any 3 odd numbers will be odd. All right, so all that closed means, it could be any set. I could be talking about any size set, infinite set, very finite set. To be closed under an operation, when I apply that operation to anything in there, the result's got to still be in there. I don't have to go out of it. I love that idea of closure means I don't have to leave. I can keep my front door closed and locked. I don't have to leave the house. I got everything I need in it, right? Because that was us during the pandemic. Okay. All right, so that was that. What I kind of want to do is I want to kind of shut up for a little bit. I'm sensing, and what I really want you guys to not feel hesitant is to ask me anything. And I'm getting a lot of people turning in homework that's just not even, things are not even tried. I really want you guys, so I don't know, I'm trying desperately to not be somebody that you can't approach, and I don't know if that's coming off that way or something. You can definitely approach me with anything. I live off of questions. And if any of you guys do end up going on to become teachers, you are going to feel, well, most of the students you're going to have, there are going to be too many questions, probably. The problem you have as a college professor is I sometimes get classes that ask nothing. And those always kind of drive me a little insane because that gives me nothing to work with. I can't gauge where people are. Very often somebody will bring something up that's the way I didn't even think about it. The whole class hears it and that improves their own experience. Does that make sense? So you kind of want to have engagement with your students because those conversations that other people hear are valid and important. They're educational. But I thought today, just to kind of like change up things a little bit, I let me see, I think I counted that there was 21 of you guys, 3, 6, 7, 8, 10, 11, 12, 14, 16, 18, 21. Okay, beautiful, I love it. Let's see, 1, 2, 3, 4, 5, 6, 7. That could get a little weird. Well, we'll figure it out. I kind of want to put you guys into groups and let you discuss something. And what I want you to discuss, well, let me put you into groups first, okay? So we're going to do it the old-fashioned way, right? So I'm going to count up to 7, and then all the ones will get together and all that kind of stuff. And then I'm going to rearrange the groups a little bit. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So find your 1s, find your 2s, so forth, right?